We know what we should eat, but our shopping carts often tell a different story, packed with too much salt, fat, and sugar, or meat. Now imagine we need to feed 10 billion people by 2050 healthy and without destroying our planet. Is this possible with this shopping cart? Probably no. And how can we do better, sustainable, ensuring the health of both people and the planet?
The basis for food security, human and planetary health, are plants. So we need to think of strategies for sustainable agrosystems, guaranteeing food security on the one hand and health by nutrition and a healthy planet on the other.
My name is Thilo Hoffmann. I'm professor of environmental geosciences. My research focuses on understanding environmental pollution and informed solutions for a sustainable future.
My name is Wolfram Wegwerth. I'm a professor of molecular plant physiology and systems biology. I'm investigating the performance of crop plants in their agroecological systems to generate concepts for sustainable production and human health by nutrition.
On November 15, 2022, humanity hit a major milestone. 8 billion people now live on this planet. And while the growth is slowing down, population is still increasing. The UN projects our population will reach a maximum population of 10 billion by 2050. As our numbers rise, so does the pressure on the system that support life, food, clean air, and stable climate. We are already nearing the planet's limits, so the question is, how can we sustain life without exceeding those limits, those planetary boundaries? Let's explore what the future holds. As global temperature rise, soil temperatures increase even more dramatically, creating a situation that complicates agriculture, including a reduction of crop yields. But this presents a significant challenge in meeting the demand for 60% more maize, rice, wheat, and soybeans by 2050. Meanwhile, a staggering 1/3 of the food we currently produce is being wasted at the farm, the retailer, or at home. Agriculture is already a major pressure on the planet, contributing to the ecosystem damage that threatens food production. Currently, 37% of the Earth's surface is dedicated to agriculture, exceeding the land area covered by forests. Agriculture drives 75% of global deforestation, clearly linking farmland expansion to shrinking forests and biodiversity loss. By 2050, 10 million additional square kilometers of land are projected to be cleared, adding 3,000 megatons of CO2 equivalents annually. However, with an alternative approach, this could be dropped to 2 million square kilometers and 1,000 megatons per year. Agriculture is a major source of greenhouse gases, responsible for 56% of all non-CO2 emissions and up to 30% of global emissions. While its share has decreased, this is due to rising emissions in other sectors, which is not good at all. As a key contributor, agriculture offers significant potential for reducing global emissions. Agriculture heavily impacts freshwater resources, with 70% of global freshwater used for farmland watering, also called irrigation, which consumes 6% of global electricity for pumping. It's estimated that irrigation will be responsible for up to 80% of global water abstraction by 2050. Overall, agriculture places the greatest pressure on planet Earth. To meet the rising demand for food, we need to increase production by 60%. Yet agriculture is already responsible for 29% of global greenhouse gas emissions, 30% of energy consumption, over 1/3 of global land use, 70% of groundwater extraction, and 75% of deforestation. These impacts hinder progress toward achieving the UN Sustainable Development Goals. This pressure is also evident in agriculture's impact on planetary boundaries. The concept of planetary boundaries helps us to assess whether our resource use remains within safe limits or exceeds the planet's capacity. Specifically, agriculture contributes to surpassing planetary boundaries for biodiversity, phosphorus and nitrogen due to fertilizer overuse. It also introduces novel entities, environmental pollutants, such as pesticides, fungicides, and herbicides, further straining our ecosystem. To put this in one sentence, civilization is in crisis. We can no longer feed our population a healthy diet while balancing planetary resources. For the first time in 200,000 years of human history, we are severely out of synchronization with the planet and nature. This crisis is accelerating, stretching Earth to its limits and threatening human and other species' sustained existence. In summary, we must take action both individually and collectively. We cannot achieve the UN Sustainable Development Goals without addressing the broken food system.
So, what are the solutions to tackle these problems? One important take-home message is the solution are the plants itself. They are the basis for food security, human health, and planetary health. Plants are the dominant life form on Earth by representing 80% of the total biomass, mainly terrestrial. Why is this so? Because of the process of photosynthesis. Plants are the primary producers on Earth, able to take the light energy from the sun and convert this with uptake of CO2 into organic material. We rely on this organic material as primary and secondary consumers. We degrade the organic material to generate energy and release CO2 again, which is then fixed by the plants by the process of photosynthesis. A perfect balance between photoautotrophic and heterotrophic organisms made by nature. Despite the diversity of edible plants, we are using only 3 major crops, wheat, maize, rice, for 40% of our daily calories. This is a mistake. 1 degree climate warming has a major impact on plant productivity of these crop plants, leading to food insecurity. We need to develop climate and food smart crops and to promote underutilized crops with better climate resilience. Taking all this together, agriculture production needs a significant transformation. The key for this significant transformation can be summarized as agroecology. The major themes are productivity, stability, sustainability, and equability. And these are system properties need to be considered simultaneously. These are fundamental systems theoretical principles, and consequently, it is a demanding interdisciplinary approach, as shown here by the scheme of the FAO, the Food and Agriculture Organization. From responsible governance to circular and solidarity economy, different areas are integrated into synergies. And on top there is biodiversity. This is covered by so-called germplasm collections and biobanks. Since the 60s of the last century, there's an international network of non-profit plant breeding institutes, hosting altogether the largest biobanks on the so-called mandate crops. Institutes from Mexico to India are linked by the Consultative Group of International Agricultural Research, CGR. And we are working closely with them together on large germplasm collections. Using these large germplasm collections, we can develop climate and food smart crops for future. We are working together with the CGR Institute on a germplasm collection of more than 1,000 different cultivars and land races of pearl millet. Pearl millet is a typical underutilized crop, but in contrast to wheat, rice, and maize, much more drought and heat resilient. This is one exciting example of an underutilized crop species, which has great promise as a climate and food smart crop of the future. I come now to another problem which we can address with these international germplasm collections. The nitrogen problem already introduced by Thilo. We have fed the world population in the last 80 years with increasing plant productivity gained by excessive synthetic nitrogen fertilization. The problem is an excessive usage of nitrogen to push plant productivity to its limits to feed an ever-growing world population. However, only 30% end up in the crop. Why? Because up to 70% of the fertilizer does not reach the plant, but is leaked into the environment by a process called nitrification. Here, bacteria and archaea oxidize the soil-retained ammonium to nitrate, which is then leached from the soil into the groundwater, producing enormous environmental pollution. At the same time, nitrate-dependent denitrifiers produce large amounts of one of the strongest greenhouse gases, nitrous oxide. Indeed, agricultural soil management contributes 78% to the total release of nitrous oxide. This produces a dilemma. How do we feed an ever-growing population while preserving healthy soils and environment? The solution is the plant itself and its interaction with the soil. The whole system is called the holobiont. Plants secrete compounds from the root system which are able to inhibit the nitrification of the bacteria in the soil. This process is called biological nitrification inhibition. This lowers the nitrate leaching, nitrous oxide emission, improves nitrogen use efficiency, plant productivity and stress resilience, and will lead to less nitrogen fertilization. We are testing these properties currently in the large germplasm collections of the CGR network. Merging all this together, human and planetary health, results in the global concept of planetary health diet. It is important to shift existing agrosystems away from animal-based food production because this is way more resource intensive. This requires that we extend the proportion of protein-rich plant-based food in terms of legumes, such as chickpea, soybean, and others. And now back to systems thinking. All subsystems are intimately bound to each other. The agricultural production systems, planetary boundaries, and human health boundaries. And we can look very much forward to plant-based food. Vegetarian and vegan food has thousands of years tradition in Japan and India. The 40s Japanese emperor Tenmu enacted a law to prohibit the eating of animals in the 7th century. In the Buddhist temples, the monks follow a very strict vegan diet called Shojin Yori, literally the food to attain enlightenment, since more than 1,000 years. In conclusion, we can summarize agricultural production systems need to undergo significant transformations to feed an ever-growing world population, and the crop plant is the center for this transformation. Agroecology based on an interdisciplinary approach, integrating governance, circular economy, sustainability, and biodiversity is the key for future agro-system structures. International research networks, such as the non-profit CGR institutes and the plant biobanks, are the key to develop highly resilient, productive, and at the same time sustainable crop systems. A global systemic concept is important to guarantee food security, human and planetary health. We hope very much you enjoyed our presentation, and there's much more to say, of course, but we would be very happy if you simply contact us to know more about these topics. Thank you very much.